it's Mr. Fletcher here. So we're going to be looking at similar shapes here, so specifically the area of similar shapes. So in the question we've got the statement that A and B are similar shapes. So the first thing we just need to realise is that's a key piece of vocabulary. So we'll just put that in highlighter. They are similar shapes. We need to find the area of shape B. So because we know they're similar shapes, we know we don't need to go away and do anything weird with rectangles and triangles and chopping it up into bits and trying to find individual bits of area. We know we need to use the rules of similar shapes. So what we do know is that the scale factor of the lengths can be found using the lengths 5 and 15 because these are corresponding lengths. So up until now you've probably just been calling that a scale factor. Now I'm going to call it a linear scale factor, okay? And that is going to be equal to 15 divided by 5, which of course is 3. Now all we need to know is that the way we find the area scale factor, so the area scale factor is going to be the linear scale factor squared, which is 9. So that's what we need to know, is that the area scale factor is always the square of the linear scale factor. If we were going the other way around, we would know that the linear scale factor was the square root of the area scale factor if that's what we had, but that's not where we're going here. Okay, so now we know what our scale factor is, and we know we're going from A to B would be times 9 for area, and if we were going the other way, of course, if we were going to the smaller shape, we would be divide by 9 for area. Okay, so what we need to go away and do then with our calculators, because these are usually calculator problems, is we're given an area for the smaller shape. So the area for B is equal to the scale factor times by the area that we've got. That can be done with our calculators. I mean, obviously we can use a written method to do that. 9 times 28 is 252. So 252. And what are our units going to be? They're going to be centimetres squared. Okay, and then we are done.